So hello, my name is Anurag and today I'm going to solve the new problem on dynamic programming, that is frog jump. So let's try to understand the problem. The problem is given an integer array height where height I represent the height of the ith stair. A frog starts from the first stair and wants to reach to the last stair. And suppose whenever the frog is on ith stair and he wants to jump, so he has two options, whether he can jump two steps or one steps. And for that steps, he has also to pay some cost, like the cost of jumps is absolute difference in height between two stairs. So let's pick this test case and try to uh, understand the problem more. So I am copying this test case and pasting it here on Xlidra. And here we have the array is given as 20, 30, 40 and again 20. So let's suppose the frog is initially here. So he has two options, whether he can move to two steps or go single steps. And while moving, he has to pay some cost. That cost is equal to absolute difference of the heights 20 minus 40. In case he is moving one step, like here from here to here and from here to here. So while while moving from the last stair to the first stair, we have to find the minimum cost. uh, so in order to find the minimum cost, we have to explore all the paths from which the frog can go to the first stair from the last stair. So in this problem also frog has different options, like he can take one steps or two steps. So the the approach that comes to my mind is recursion, in which we go and explore all the options and try to build the tree. So here we will try to build that tree. So the last we will start from the last index, that is 0 1 2 3. So we will start from the last index f of 3 and explore the couple of options that frog can take. So in the left side we will explore two steps, and in the right side we will explore one step. So suppose the frog has taken two steps, so from third index he can jump to first index. And don't forget about the cost. He has to pay a cost of jumping, that is 20 minus 30. And let's explore the second option of one step. Moving one step, frog can go to the second index, and he has to pay cost also, that is absolute difference of 20 minus 40. So we will explore go and explore other states also, like suppose the frog is on the first stair. So on the first stair, he has two options too, like from here he can here he can take a single steps and take double step. But taking double a step doesn't mean anything. He can't reach the stair he wants to. He can simply go out of the array. And so we will not explore this path, and we will explore this path in which a frog can take one step and go to its final desired position. So here f of 0, taking one step, frog can easily go to here, and we will explore this state. So currently frog is on the second stair, and he has two options, like jumping from second stair to first stair. So it became f of 0. So this is the final desired position that frog wants to reach. And also here, on the from the second stair, frog can take a single step and go to the first stair. Also he has to pay some cost, that is absolute of 30 minus 20. Here also absolute of from second to 0, it means 40 minus 20. And also from here to here, from 2 to 1, he has to cost to absolute of 40 minus 30. So let's explore this too, and this will be the last. Then we will try to calculate our answer from this tree. So f of 1, we here we are taking two steps. So as I told you that we taking to a step from index 1, will we take us out of index, out of array, and there's no any point of exploring this part, so we will not explore this part, and so we will go here. Taking a single step will take frog to the final desired position, that is f of 0, and costing him absolute of 30 minus 20. So now we will try to calculate our answer. So we have to in the question we have given that we have to find the minimum cost. So at every state we will try to find the minimum. What is the minimum, which path is giving us the minimum? So we will start from the base cases, like f of 0 is considered as base case in the recursion. Like f of 0 will give us 0, because the cost of reaching the a state on which he wants to reach is 0. Like he is already present on that state, so this will return 0. This will return 0 too. And talking about this will we will write int max. Like there is no way of no any point of exploring this path, and when we take the minimum of these two, the minimum will be taken as f of 0, and we move forward. And don't forget to add this cost. So we will add the cost, like 0 plus 30 minus 10. It will be the result of this function call will be 30 minus 20, that is 10. So now we will get here. So the minimum of these two will be 0 plus this, means 0 plus 10, the, the result of this will be 10. And more, and then we will move forward. So from here we are getting 0 0 plus 40 minus 20, that is 20. And so from this side we are getting 20, and from this side we are getting 10 plus 40 minus 10, 40 minus 30, that is also 20. So from both sides we are getting 20, so the minimum will be 20. The minimum of these two, 20 and 20, so this will be 20. Now for this function call is giving us 10, this function call is giving us 20. So we will take minimum out of these. And so the above returned value will be 20 minus 30, that is 10. 10 plus 10, that this is returning 20, and this will be return 20 plus 20, like 20 minus 40 will be 20, and 20 plus 20 will be 40. So we will take the result of this path, not this path, as we have to find the minimum cost. So the final result will be 20. Let's check the answer. So you can see that the result is 20. Now let's try to code this in C++. I'm coding this. So this is the function given as minimum cost. So we will make a helper function that is return solve, and pass it the last index int of n. Int of n will be height dot size. So we will pass it here n minus 1 and the height array he, and then we will write the helper function above int solve. So int solve int n, and we will take the vector and pass it by reference heicst, and we will take two variables, cost of moving two steps and int cost of moving one step. So this will, for this we will take the value, we will call the function solve, like we will go one step back, one step ahead, going from last index to first index. So it will be n minus 1 height, and the cost too, we have to include the cost too, that is height of n and minus height of n minus 1, and here also solve n minus 1, sorry, not n minus 1, n minus 2. In this we are taking two a step ahead, starting from the last index and moving to the first index. So it will be height plus absolute of height n minus 2 and minus height of n. So and at last we will take the minimum of these two, return min of and we also write the base case if n is equal to 0, means we are on the desired position. So we will simply return 0, and we will add a condition to if n is less than 1. If n is less than 1, then so we can't go and explore the negative indexes. So what we will do, we will initialize this variable with int max, like in the while making making the recursion tree I have shown, I am returning the int max. So we will initialize this variable with int max in case we are getting, so we will only call make this call if n is less than n is uh, n is greater than 1. We will only make this call if n is greater than 1, and in other case it will be still int max. The value of cost of moving to a step will be int max. So here all everything is set, and let's run this whether it is accepted or not. So the first task is accepted. Let's submit it. So you can see that time limit exceeded. So basically it's a pure recursion approach. We can optimize this approach. So let's discuss why it's giving the time limit exceeded. Because at every suppose we have n stairs. Suppose we have n stairs. At every stairs, while going to the desired final position, we are making two calls for each one. So it will get the complexity to exponential. So to optimize this, we will use the memoization trick. Like in the memoization, we like as the memoization we store the result of computed ones. Like in the recursion tree, we can clearly see there is overlapping subproblem like f of 1. This same function is called two times. So we will try to store the result of these function calls somewhere in the vector and use that stored result moving to the same function call in the tree while solving the problem. So we will use a vector or array, and store the results of computed ones. So here we initialize a vector dp, and we will take we will take this below and write it here. So this will be n plus 1, like we are safe from the any out of index error, and we will initialize all the value in the vector as -1. We will pass this here and also write it here, vector of int dp, and here we will, before returning the result, we will store it here for the n state, and this will get over the this will override the value of -1 that is in the dp vector. And if while going deep in the tree we find that the result of this function call is already calculated, we simply return it from the here and don't go that deep in the tree. So this will optimize it, and we will get our answer in O of n time complexity. So we will return it from here, return dp of n minus 1, sorry, not n minus 1, n. And that's all. So let's run it. Oh sorry, I forgot one thing. I have to pass the dp array here also, and we will pass it here, and then we'll try to run it. So you can see that the test case is accepted one. Now let's do final submit. So you can see that the problem is submitted, and it's correct for all the test cases, and we have successfully solved this problem. So now I will solve more problem tomorrow. Thank you.